And we're going to find ourselves in the complex plane, and we're going to look at polar form of complex numbers. This is section 9.6. Buckle up, here we go. First thing we'd like to do is review what a complex number is. It's a plus bi. A is the real part, b is the imaginary part. Now, little did you know, you can graph on the complex plane. The horizontal is the real, the vertical is the imaginary. So if we were going to graph a point like 3 plus 4i, 3 is the real, 4 is the imaginary, to the right 3, and then up 4, so that would be our point, 3 plus 4i. I gave you a lot of examples on the note sheet. You can follow along. 1 plus 2i over 1 up 2, 2 minus I, right 2, down 1, negative 1 plus 3i, left 1, up 3. So those are the 3 points. There's a couple more on your worksheet. Now z usually represents a complex number. The absolute value of z is the distance from the origin. So if you think about it, it really just requires us to use the Pythagorean theorem. It's a lot like the radius when we talked about polar form. So we're going to tie those together today. So if you wanted to find that, you would use the Pythagorean theorem. If you had some point z, your distance across the bottom would be x, across up would be b. So r is really your absolute value of z. It's called the modulus. Theta is the amplitude or argument. If I give you a complex number, a plus bi, remember a represents the horizontal distance. It's like x, and b is the vertical. And there's our two conversions. X equals r cosine, y equals r sine. So you can substitute. So to rewrite this complex number as a polar, we write it in terms of x and y, r cosine plus r sine I. This is what we call the polar form of a complex number. Now, cosine theta plus I sine theta is used so often we call it the cis. So you can rewrite that as r cis of theta. Let's look at an example. Makes a little bit more sense once you do it. So if you flip it over, I think we looked at number 4, and that example was 3 plus 4i. So we plot the point. What's the radius? Well, that's Pythagorean theorem. What's the angle? The radius, plug it in, square root of a squared plus b squared, that's square root of 25. That should be r equals 5. I screwed up there. The angle, we'll use a little trig, inverse tangent of 4 over 3, and we get some angle in radians, 0.93. So we would write that as r cis of theta, so that would be 5 cis 0.93. That's the polar form of the complex number 3 plus 4i. Up next, what if we wanted to go the other way? What if I gave you the polar form and wanted you to graph it and turn it into a rectangular form? Well, if I've given you r and theta, which I have, well, that's just straight up conversion that we've been doing. We know it's in quadrant 2. The x value should be r cosine of theta, so r cosine of 135, which gives you negative root 2. And then the y value would be r sine of theta, which would be 2 sine of 135, so that'd be root 2. So our rectangular form is negative root 2 plus root 2i. That's the polar form of that complex number.